So now we're looking at question 6D from exercise 2B from the Year 8 textbook. So what I'm going to look at is trying to figure out what they're trying to ask for. They're trying to ask for this value of A. But what I'm going to do first is extend these lines, because these two are parallel lines. What gives it away? It's these guys over here. Now it's asking us to find out A, but they've given us this and this information. Now the real question is, how do we go about this question? We've got to think for a bit. So this here is 37 degrees. This over here is equal to what? This and this. Dealing with parallel lines, they're on each the opposite side, different sides. So if this is 37 degrees, this must also equal to 37 degrees. And why is that? Because they're alternate angles. Now, the other question is, how do we figure out A? Okay, we still can't figure out A. We know total angle in a triangle is 180 degrees. So if we figured out that total angle is 180 degrees, we still do not know what this one is, okay? So how do we go about this question? Okay, so we got to figure out, we also know that this is 40 degrees. So if this is 40 degrees, and we know that this is angle A, that means angle A is also equal to 40 degrees. And why is that? Because it is alternate angles. So A is equal to 40 degrees as well, because these two are alternate angles. And they're only alternate if you have parallel lines. If there are no parallel lines, you can't assume that they're alternate. It's essentially, if I was to redraw this, essentially looks like this. 40, 40. That's basically that. That's it. So there was actually no need for this 37 when I look back at it, but this is kind of like a trial and error and going with the flow and seeing what we could utilize with the information given. Hence why I went to the 37. But yeah, you might have approached it differently and may have went straight to realizing that A is 40 degrees. Okay, and that the reason for that is alternate angles.